Okay, just a quick overview. We talked about Euler's method, and we talked about, this differential equation over here with the initial condition that the function y evaluated at 0 would be equal to 1. And we talked about generating a slope field for this thing over here, and then using a method called Euler's method to fit a curve through the point where x is 0, y is 1. And we used Grapher to do that, and we came up with this over here. And then the bottom line, I also talked about, an exact solution to it, and that was this over here. Then what I talked about is the graph of both the approximate curve and the exact curve over here. And they do differ, by the way. All right, they do differ. Do they agree here? They certainly agree there, but as you start to move away, they start to disagree. So what we want to talk about is how Euler's fitting these things, and that's what we want to talk about now. And to do that, it basically just requires that you know some Math 100 material to do that. And the bottom line, what you're doing over here is you got y prime is equal to x plus y. And what you're doing over here, you're starting with a given point. The point you're starting with is 0, 1. And what you're going to do is write an equation of a line down to get to the next point. What's that going to be? Well, let me write this down for you. It's y minus 1 equals m, and then you're going to get x minus 0. Relatively simple, by the way. So the bottom line doing this over here, what you start to realize is what's m? It's just a slope. And what's the slope going to be? Well, the slope, I'm going to write this over here, at the point 0, 1 is just going to be 1. So what do you get over here? You get y equals 1 times x plus 1. All right, that's the equation. Now someone says, what are you doing over here? You have to know what the x is, and the x is going to be, in this case over here, let's take a look at that. I got to move up, don't I? So what's the step size then? And if you think about it, we're actually moving to the right 0.1. So what would you get over here? You get y equals 1. The step size is 0.1 plus 1. And what's it going to give you? 1.1. So my new point that I'm traveling along over here is going to be the x is going to be 0.1, comma, the y will be 1.1. Let me point out the first point we got was 0, 1. And one thing you know about this thing over here, the tough thing is to compute the y. It's not the x, by the way. What's the next x going to be? 0.2. What's the next one going to be? 0.3. We're just moving up by step size, 0.4. These are the tough things to compute, all right? And I want a general way of doing it, all right, a general way of doing it. And the way I'm going to look at it is, and again, we're going to generate a formula now, is to compute these guys over here. And the x's are really easy to compute, by the way. For example, you're given an x, an initial x, this is going to be 0. You're given an initial y, that's 1. These are super easy to compute, by the way. All you're doing is adding the step size each time. That's all you're doing. So 0, 0.1, 0.2, 0.3, 0.4, I have no trouble computing those. It's computing the y that has so much trouble. So let's write this down over here. And as I do it, I'm going to talk about as an abstraction over here. And what I'm going to do is talk about what it's y minus y1 equals m x minus x1. That's an equation of a line, by the way. So let me write y down over here. But I'm going to write down, it would really be y2. So y2 would equal m, and then x2 minus x1 plus y1, right? But I need a more general form of that. And the more general form is simply say, I want to talk about if I were doing the nth one. By the way, m is still a mystery at this point. What are you going to get over there? xn minus xn minus 1 plus yn minus 1. Now, before I do anything, I want to point out that this thing over here is rather easy to compute. And why is that? That's just a change between the successive x's. And the change between the successive x's is always going to be h. Let me back up a little bit. It's always going to be h. So this over here is just h. So I'm going to write that down. So yn, whoops, I didn't mean to do that. Yn, let's worry about the m a little bit later. That's going to be h plus y and minus 1. All right, what's m? M is a slope. And I want to point out, the slope here is going to be a function of x and y. Let's go back over here and get my eraser out. I can start to write that down, try to figure out what that is. So M, right, is going to be a function. Well, I don't know y2. I may know x2, but I don't know y2. So I can say it's a function of x1, y1. All right? That's what M is. So if I move up to this level over here, get my eraser out again, what am I going to get? F is a function of xn minus 1. I need more space over here. I'm going to get my eraser out. Let's write this down. So yn is going to be a function, and again, a function are differential equation, by the way. So it's going to be x n minus 1 comma y n minus 1 times h plus y n minus 1. This is a general formula, by the way. I want to go back up here, and like if I'm putting numbers down over here, let's just see if what we just derived is reflected up here. So y1, that's y1, would be y0, I see that, h, and then y prime, that's this thing over here, and that's going to be x0, y0. It looks fine. Like if I did this one over here, what would y9 equal? Well, let's write that down. Let's do y10, because right here. y10 would be equal to f of, well, that would be x9, y9, h plus, and what do you get there? yn minus 1, that would be y9. Am I getting that over here? Of course I'm going to see here. This is really important. However, I still don't think it's easy to compute. So what I'll show you is how to do this on a computer, all right? When I do it on a computer, what you're going to see me do is you're going to see me compute the successive points, by the way. So like I'll say the first point is going to be 0, 1. The next point, we just computed that, right, was 0.1, comma 1.1. The next point would be 0.2. And the X are really easy to do, by the way. So what I'll go through that, and what I'll emphasize to you over here is that I'll get these points over here. Now granted, when I do it on a computer, I'll have far more precision, but I'll still get those points, by the way, within that level of precision. And again, you want to watch that video so you can do that yourself. Thank you.